Oh, hi, guy. This is my bonus mark answer question 3. The question states that you have to consider a two-dimensional case of a uniform right triangular sheet of mass m and height h and base b. The thickness may be neglected. Determine mathematically a vector that identifies the center mass of the sheet in terms of h, b. Discuss and show your mathematical reasoning. So this is A, and I've got B ready to go. For this question, I chose to do it on a 1 by 2 triangle, so x is 1, y is 2. And for this question, we need integration because it's not simple enough just to do the normal center mass of the one-dimensional case. And so I'll just do a close-up just to explain what's going on a bit. So this is my triangle. ignore this here because that's the center, but I'll show you how I got there. This will be the dA, which is just the area of this little sliver, and you'll be integrating it all later on. But yeah, so just later, this is the slivers of the x and the y. So I don't know if you'll be able to see it because it's a bit blurry, maybe, I don't know, until I load it up really. But yeah, that's the center mass integration equation that we're going to be using. Yep, I'll just start explaining it a little bit. Let's see if I can move this a bit closer, which I can't. Okay. So yeah, that's our center mass equation. And you have to do it on each axis. It'll be the integration of dA, which is that sliver that I showed you, and xcm, which is the center of each dA, center mass of each dA, sorry, over the dA of that sliver. And the equations for the x-axis will be dA equals 1 minus x, this 1 minus x, times the dy, and the center of x will be the 1 plus x divided by 2, which would be center of x. And because you have a dy, you need to get everything in terms of y for this equation to work properly. And to do that, we need to find the relationship between x and y, and that is obviously the line, the equation line of that, which is y equals 2x. So every x goes to the right 2 up will be the relationship for the y. It's the basic linear equation. So now we've got out y over 2, which is x. We can sub that into the dA and the center of x. So the dA will be 1 minus y over 2, and the times dy, obviously, because of that height there. And our center of x will be 1 minus y over 2 over 2, because you're halving it to get the x. So if you put that into a equation, simplify it, we'll get the 1/2, which came out of this center x. A little plus here, put the plus, which come out of our center of x from here. Then we have the integration of 0 to 2, because you're going along the y-axis, and it'll be 1 plus y over 2 times the dy, which is still our height here, over here, and then over 1 minus y over 2 dy, which is still the height, or the integrated dA, and it'll be 0 to 2, obviously. That will simplify down to half. the integration of 0 to 2, 1 minus y squared over 4, because if you differentiate that, that'll give you 2y over 4, which will go down to half of y, which is here. So you need to go back and do 2y over 4, and this will just stay the same. No, it won't. I'm sorry. You'll be expanding these out, so it'll be y 1 squared plus y over 2 minus y over 2 minus y squared over 4. So, and you come down here. I'll move it up. Let's got the iPad going as well. Move it up. So you need to get the integral now. So it'll be 1 over 2, and you get the y minus y to the cube over 12. If you differentiate that, it'll be 3y squared over 12, which will be 1 over 4 y squared, and that's what we got up here. And the same case for down here, but that's all good. And then we simplify a little bit more. And then we add the 2, because the integral, obviously, that's half of y, so 2 minus y cubed over 12, which is 8 over 12, which you can simplify back down to 2 over 3. That's half of 2 minus 2 over 3 over y minus 2 squared, which is the y squared here, over 4. So 4 over 4 is 1. That's 2 minus 1. And that's just the half of the 4 cubed, which will be just pretty much times the denominator, which will be 4. 4 over 3 times the denominator, which will be 4 over 6, which you can simplify back down to 2 over 3. So that unit, amount of the quantity that you're coming across from the x will be 2 over 3. That'll be your base. So 2 over 3 this way, that's our I component. And I got it on the back of the sheet, yeah. So that's the I. So now you move on to the y. So that y, we're coming down to here, the center mass of y, will be the exact same, except instead of the center of x, we're doing the center of y. Instead of doing 0 to 2, we'll be doing 0 to 1, because it's over here. And we're going to be doing, instead of y over 2, when we're going to find the relationships in terms of y, we're going to keep it as a relationship in terms of x for the dA. So if we come over here, our dA will be over here. I'll just zoom in because it's small. The dA for the y will be dx, y dx, and y, the relationship is y is 2x. So that 2x will go into y, and that's our dA is 2x dx. And our y center will be the y over 2, because you're dividing by 2, and then comes from 0, and then the 2 over 2, which can just be simplified back down to x. So that's that equation there for our y center mass. And let me just put it here. So down here, so we get our dA times the y center divided by the dA integral, and if we keep going, it'll be the integral 0 to 1, 2x dx times x over 2x dx, integral as well, and that can be simplified down or differentiated or integraled back. Simplified, it will be integraled back, so we get integral y will be our x cubed over 3, because we're taking it back up, and there'll be 0 to 1, and our denominator will be the x squared over 2. This will be integral of the that denominator over there. If we sub it all in, so we can get the max, so it goes sub in the 1 on top and bottom. It'll be 1 over 3, or 1 cubed over 3, and 1 squared over 2. Be 1, 3, and divide by 1 over 2 is the exact same as times by 2 over 1. So that's 2 over 3. That's our unit for the H. And we have our unit for the B. Geez, wait. Okay, let me just zoom up on that. Get the lighter back on. Zoom up on that. So it came from... Oh, sorry, let me just set it up. I might have probably scared you. Anyway, integral x, we see there, that's just that line. Just that line scared me. That line with subbed in from here, and that's the simplification from there, and integral. That'll give you the 2 over 3. Hopefully you can see this clearly, because I don't know how it lights up all the time. We get a center mass of y, which will be the equation there, subbed in from up here, and then the integral here, and we sub it in, and we get out 2 over 3, and it's a vector form, a vector that identifies the center mass, and that'll be the equation there. That identifies our center mass of the triangle,